Okay, so today we're going to take a look at if loops and while loops. Okay, so two kinds of repetition structures. I'll go ahead and share my screen. All right, so now we're seeing everything. Let me move this Zoom window out of the way, and didn't mean to hit the apps button right there. Okay, I move myself out of the way over here so I can see the. Let's move it over here. Be able to see the PyCharm a little bit better. Okay, so what a for loop is going to do here, you can see I've got a comment here is a for loop. Well, here it doesn't have an if statement yet. We're going to have an if statement and a break in just a minute. This is an example that I used for the notebook last week for the notebook chapter. So here we've got a list of bands. So we're going to set our variable bands equal to Beatles, Led Zeppelin, Pink Floyd, and U2. What this for statement is going to do is it's going to iterate over these four band names right here, and then we've assigned X as each item in the list. It's going to iterate over the items X, which are the band names. Then it's going to print X, and when we do that, let's see down here, we've got Beatles, Led Zeppelin, Pink Floyd, U2. So we've got our all the items in our list. Now, if we want, we could actually put in an if statement to work within the loop. So our conditionals will work within repetition structures. So for example, here, or you could say, for example, if X is equal to Pink Floyd, then, oops, excuse me, go back here. Punctuation is important. We're going to put a colon right here, and we'll break. Okay. So the break is going to take us out of this loop. So if it gets, so it's going to be printing X. Here it's going to iterate over Beatles, Led Zeppelin. Then when it gets to Pink Floyd, at that point, X will be equal to Pink Floyd. That'll be the item that we're iterating over. So we're going to break out of the loop and it won't print anymore. So we should just get Beatles and Led Zeppelin here. And sure enough, Beatles and Led Zeppelin, when we got to Pink Floyd, we broke. So in the last video, we talked about if statements. We talked about break as a way to get out of our, we talked about for loops, and we talked about break as a way to get out of a repetition structure. So to get us out of a for loop or a while loop. Okay. So we've got a couple of other examples we want to look at. I'm just going to delete this right here for now. We're of course looking at PyCharm, but I had written a little bit of code, and I just saved it over here in a Jupyter notebook on Google Colab, just so I could copy the pieces that I want to use to demonstrate right here. Different principles. Let's see what the next one I wanted to look at was. Okay. So here we've got an example of a while loop. Let me just go ahead and copy that. Well, just want to copy this right here. Okay, we'll go back to PyCharm and we'll paste that in. Okay, so here we've got an example of a while loop. So for a while loop, what we're going to do is we're going to have an operation that's going to be working while a certain condition holds. So if we don't know exactly how long it's going to hold, like with a for loop, we can use a while loop. So with a while loop, you have to initialize your variable. So here we're setting our variable I to 1 to begin with. So while I is less than 11, we're going to print I. Okay. So if that was all we had right here, if we didn't have this part, then we would just have the number 1 printed over and over and over again in an infinite loop. Okay. So we don't want that. The way to get I to be not less than 11 is to increment. So here what we're going to do is after we print the I, we're going to add 1 to the I. So we could do that in two ways. We could say I equals I plus 1, and that should work for us. See, we got up to 10, right? Or a shorthand way of doing that, instead of I equals I plus 1, is we can just write I plus equals 1. So we use an augment command here, plus equals 1. increment, augment, I said, but it's called an incrementer, right? And we have something similar. We've got an incrementer, we've got a decrementer. If we use minus equals 1, we can use multiplication. We'll look at an example of that in just a second, but just to show this does work, there we go. We get the same output as we did when we had I equals I plus 1. So what happens is, as long as I is less than 11, we're going to print it. Once it get, and then each time we're going to add 1. So we're going to have 1, right? Because that's our initial variable that we set here. Then we're going to print it. So at that point, I is less than 11 because 1 is less than 11. So we're going to add 1 to it. We get 2. We print that. It's still less than 11. Once we get up to 10, we print that. Then we add 1 to it. Well, that is 11. So I is no longer less than 11. And our loop ends. Okay. So we'll go ahead and delete this bit of code as well. And then the next thing I wanted to show you was other kinds of accumulator variables. So yeah, we could do it this way. And right here, we're going to calculate a running total using an accumulator variable. So again, like with the while loop, we're going to begin by initializing a variable. So the number that we're going to be counting, we're going to call the variable total. Then here we've got a list of numbers from 10 down to 1. So what we're going to do is this is going to be a way of calculating 10 factorial. So 10 factorial means 10 times 9 times 8 times 7 on down to 1. Okay. So what we're going to do here, the code says for num and numbers. So here's our list that we've called numbers. Num is just, it's a convenient way of thinking what we want to call the item here. We can call it anything else like X or what have you. For num and numbers, we're going to have the total. So that's the value that we start with initialized as 1. The total is going to be whatever the total is times the next number. So to begin with, we've got 1 is the total times equals. So total times equals number is total times this number. And we're going to do that for all of the items and numbers. So for all the nums and numbers. So we're going to have 1 times 10, which will give us 10, times 9, which will give us 90 on down the line. Okay. And then that value is going to be stored here as total. Then we can just use a formatted string here, print the total of all the numbers in the list multiplied together is, and then it'll be the total, right? And because this loop is going to run until we get to the last item in numbers, we're going to get that total of, we're going to get 10 factorial. So we go ahead and run the code. And my video is in the way here, and now we should be able to see it. The total of all the numbers in the list multiplied together is 3,628,800. Of course, that's that demonstrates using a for loop with an incrementer, in this case, a multiplication incrementer rather. But there is an easier way of figuring factorial than actually writing, because if you've got you're looking at let's say the number of ways that a deck of cards can be shuffled, which would be 52 factorial, because there's 52 cards in the deck. That would be a lot to write out. 52 times 51 times 50 times 49. It would be a long string. So a shorter way of doing that would be like this. There's actually a factorial function in Python. So we'll just copy that, bring it over here. I'll get rid of this code. Okay. All right. So what we're going to do first, we're going to import math. Python's kind of cool because you can import functions that you need. You can import libraries. You can do some cool stuff with it. We're going to declare a value here of a calculated value, and it's going to be this math.factorial. So we're calling the factorial function. It's a built-in function to math in Python, a factorial of 10. Then we're going to print this calculated value, and we should get the same thing as this right here. So if we print it, there we got the same number, 3,628,800. That's just a shorthand way of doing it, but we wanted to look at how to do it by having a for loop with increment or variable, in this case, multiplication. You can do exponents, you can do bitwise calculations, all sorts of things with it. Let's look at, I talked about some of this other stuff, how to add zero padding and whatnot for how to do formatting with decimal places. But I don't think we necessarily need that in the video. It didn't say it in the instructions, so, but I had put it in my notebook chapter. But I think one thing that would be good is to take a look at how a nested loop works, because that is part of doing loops, to have nested loops. So one loop embedded within another, and here would be an example of that. Here we've got two lists, right? So the first one we're going to store in the variable adjectives. So our adjective items that we're going to store are fast, expensive, and efficient. Then we've got vehicles, and we're going to store a couple of vehicle names. So we've got a list of Mustang, Skyline, and Funky Cat. Funky Cat is a new electric vehicle that's now being manufactured in China, and they're starting to sell some of them in the West. I mean, I think they're selling them in Europe now, and starting to sell some in the US. Skyline is I think Skyline, it's a Nissan, and it was the sports car that was kind of the inspiration for the Nissan GTR. I don't think Skylines are sold in the US, but some people import them from Japan. So anyway, what we're going to do is we want to match each adjective to each vehicle. So to do that, we'll have for X an adjective. So first we're going to iterate over this list. We're going to have fast, and then expensive, then efficient. But as we do fast, as that's happening, for each one of these, we're going to iterate over this list. So we're going to go fast as our first iteration over adjectives, then it's going to iterate over all three of these. So we're going to get fast Mustang, fast Skyline, fast Funky Cat. Then we're going to go to the next item in adjectives, the next X in adjectives, expensive Mustang, expensive Skyline, expensive Funky Cat, and so on with efficient. So for X in adjectives, for Y in vehicles, we're going to print X, Y. So for each X in the adjective list and for each Y in the vehicle list, we're going to print X and Y. So we should end up with fast Mustang, fast Skyline, fast Funky Cat, expensive Mustang, expensive Skyline, expensive Funky Cat, then efficient in all three vehicles. Let's see when we run the code. There it is. So let me move myself out of the way here. Fast Mustang, fast Skyline, fast Funky Cat, expensive Mustang, expensive Skyline, expensive Funky Cat, efficient Mustang, and so on. Right? So that's a way of having one loop, so one for loop embedded within another for loop, and we call that a nested loop. All right. Thanks for watching.